Good morning and welcome back to our video series. Previously we tackled the issue regarding light intensity and we debunked the common belief that light intensity represents a quality parameter of light in the operating room. We discussed as to how the quality of a light with reference to a surgical lamp is rather made up of two components: color rendering and color temperature. Today we will therefore address color rendering. First, we will try to understand what color rendering is. We will analyze the most common method for its evaluation. We will try to understand the criticisms of this model. And finally, we will delve into alternative models suitable for evaluating the color rendering of a light source. So, what is color rendering? The color rendering refers to the capacity of a light to accurately represent the color of an object. This definition is established by the International Commission of Illumination. Let's start with a premise. Color is not an intrinsic property of an object, but is a visual perception developed by the observer and depends mainly on three aspects: the observer himself, the nearby objects, and the characteristics of light that illuminate this object. Therefore, light with high color rendering allows to improve the quality of life, as it might truly depict the colors of objects, and, with reference to its use in the operating room, allows to easily distinguish between the various tissues. How is color rendering calculated? The International Commission on Illumination not only defined what color rendering is, but also created a model that can calculate the color rendering of artificial light sources. For this calculation, they thought of comparing the color rendering of an artificial source with the color rendering of a light considered as standard. The numerical value then obtained by comparing these two types of lamps creates a scale ranging from 0 to 100, where 100 represents the maximum value, that is, the greatest correspondence of color rendering between the source taken under consideration and the reference source. Actually, the color rendering index value, normally defined as R with a, does not directly represent the comparison between these two color renditions as much as it represents the arithmetic mean of the comparison of 8 test colors between the source under consideration and the reference source. Researchers have demonstrated that the initial 8 test colors did not fully encompass the entire light spectrum. They also argued that relying solely on these 8 elements was insufficient for determining the quality of light. Consequently, additional test colors were incorporated over time, resulting in a total of 15 test colors. This expansion played a pivotal role in distinguishing the calculation of the color rendering index, leading to the implementation of 2 distinct measures: the simplified CRI and the extended CRI. The simplified CRI, or simplified color rendering index, is based only on the original 8 samples, whereas the extended CRI is based on the comparison of 15 sample colors. However, whenever we speak of color rendering index, we usually refer only to the original calculation, that is the one based on 8 sample colors. Several critics have also been submitted with reference to the color rendering index used in the operating field. The first criticisms made by the researchers is about the test colors. The 8 test colors are not really representative for the medical environment, since these 8 samples lack the analysis of red, called R9, i.e. the 9th test color, which is really needed in the analysis of a light for operative purposes. What happens then in the surgical environment is to consider the color rendering index and integrate this value with the color rendering for R9, since red is a fundamental color during surgeries. However, it is worth noting that there are other possible additional values, namely the R13 and R15, which can be of interest for examining the color match of Caucasian and Asian complexions. In total, these 3 options may provide valuable insights for the medical field. Yet even adding these values to the calculation using the color rendering index does not appear to be fully functional. The same International Commission on Illumination, the body that first developed this index has now referred to it as inadequate, especially in light of recent technological developments. Extensive research throughout the years has produced 5 areas, 5 categories where criticisms of the color rendering index can be identified. The first major criticism is precisely the comparative aspect. The color rendering index is not an absolute value, but presupposes a natural and true light condition, which is absolutely impossible to achieve given the subjectivity in color perception. Although contested in the calculation of the color rendering index, the comparison mode is the only viable way to measure color rendering, even with reference to other models. Hence, even with reference to further models, a solution to this criticism does not exist. Therefore, this is a criticism we should not consider as such. The second criticism, and this becomes a real criticism, concerns the color temperature. The color rendering index does not take into account the color temperature of a light source. For that reason, it utilizes the same technique for calculating both a lamp with a very low color temperature and one with a high color temperature. Moving forward, the third critique specifically pertains to the lack of test colors. In the calculation of the CRI standard, only 8 test colors are in fact considered, and these, as we have had the opportunity to discuss at length, are not representative, and certainly even less so in the hospital environment, where it is necessary among all to consider the value offered by the reproduction of red. That is the R9. The fourth criticism still concerns the limited number of test colors and does not cover the 8 simplified CRI test colors, but focuses on the 15 extended CRI test colors. However, not even these 15 test colors can accurately represent the entire range of colors in the illumination spectrum. This is because they do not consider the vibrancy of the colors and struggle to differentiate between colors of similar hues. Finally, we come to the fifth critique, which addresses the shortcomings in the consideration of saturated colors in the analysis of these 15 test colors. Regarding the last 3 critiques, an ulterior issue is the ability to manually adjust lighting parameters in order to optimize the color rendering index, but at the expense of accurate color representation. This can result in achieving an impressive performance on paper, while in reality, the colors appear quite inaccurate. Let's consider the example of an operating room lamp, which generally falls short in terms of the standard color rendering value, specifically regarding the value for R9. However, this value can be easily enhanced by incorporating red LEDs, thereby significantly improving the color representation on paper. Unfortunately, this improvement comes at the expense of the actual color rendering of the lamp. Despite the criticisms leveled against the color rendering index and its reliability, this index remains the sole universally recognized and legally accepted framework for evaluating the color rendering of an operating room light source. The IES 66012-41 standard specifies that an operating room lamp must generate a color rendering index between 85 and 100, notwithstanding the breadth and generosity offered by this range. 85 has been specifically picked as the base value for surgical lamps because it has been proved to be the maximum value that human eyes can perceive. Nonetheless, manufacturers of operating room lamps tend to produce lamps with color rendering values much more inclined to 100 than to 85. Research indicates that the human eye can only detect values below 85, implying limited perception beyond this threshold. There are rarely any practical situations where color rendering values exceeding 90 are required. Therefore, it appears to be only a scholastic exercise to attempt and require a higher color rendering value. We must also take into consideration that surpassing a color index value of 95 significantly diminishes energy efficiency. Hence, it is important to acknowledge that for each index value above 95, a considerable loss in energy efficiency occurs. Therefore, a surgical lamp in the operating room ought to be displaying a color rendering index between 90 and 95. It is both right and desirable to assess the quality of a light based on its color rendering. However, it is also justifiable to explore an alternative method to the color rendering index, as it has been shown to be inadequate. The focus should be on finding a comprehensive and accurate measure for evaluating color rendering. But are there other methods or other models that measure color rendering? Yes, there are different models envisaged for the purpose. Over the years, several different systems of calculating color rendering have been proposed, and among them, the one that has achieved the most agreement is the TM-30 calculation. The TM-30, unlike the color rendering index, does not take into account only 15 color samples. It takes into account 99 of them, and these 99 color samples are derived from the analysis of 100,000 spectra. Moreover, the TM-30 makes it possible to consider the color temperature of the light source under examination and evaluates the saturation and vividness of colors, and precisely because of these characteristics, the TM-30 is preferable to the color rendering index, as it is more reliable in its evaluation of the color rendering of a light source. The hope, therefore, is that the norm may move from the demand for a color rendering index value to a value of TM-30 as precisely more representative of color rendering. In summary, what have we learned today? We now understand the concept of color rendering, which refers to a light's ability to accurately display colors. We have also discovered that the color rendering index is the standard method used to evaluate and measure color rendering. Moreover, we explored two tests for assessing the color rendering index. The first test uses 8 test colors and is considered the standard, while the second test employs 15 test colors and is referred to as the extended version. However, both of these methods have faced significant criticism due to their inability to truly represent color rendering. Taking this into account, we then examined the normative requirements for color rendering in the context of an operating room. Expanding on this idea, we conducted a thorough assessment of potential future advancements. One such advancement could involve substituting the request for a specific color rendering index with a specified value of TM-30. Thank you for your attention.